Hello everyone, good morning. As part of today's session, we are going to talk about mainly what is database and what is warehouse. Okay, what is the difference between database and warehouse? Then simply we'll start with SQL. Okay, SQL. As part of SQL, how to create tables. Guys, can you please go on mute? Okay. As part of SQL, how to create database and how to create tables. Okay, and how to insert the data and how to insert bulk data by using Snow Web UI. Okay. So these are the things we are going to discuss about today. Before going to start today's session, can someone please tell me what is Snowflake? Did anyone? Can you please unmute?
No, it's a cloud-based data warehouse platform.
Yes, it's a data warehouse. Correct. Snowflake is a cloud-based data warehouse platform. And what is the second point? Mainly we are going to use it for data storage, data processing, and analytical solutions. Next, it is built on top of AWS, Azure, or GCP. Next one, it is a SaaS model. It is a SaaS. SaaS is nothing but software as a service. Software as a service. So here we no need to install any software. Okay, no need to install any software. So they have already built one application for us. So just we need to create one account and we need to use it. In last class, I asked you to create Snowflake account. Okay, how many of you are created? Just please confirm in the chat box. It's very simple how to create. Just to go to browser app.snowflake.com. Okay, app.snowflake.com. So app.snowflake.com. Here you need to sign up. Okay, here you need to sign up. You need to provide first name, last name, your email ID, your company name. Okay, role. Then once you click on this continue, just you need to select the cloud platform, whether it is Azure, AWS, or GCP. So if you are not yet created, please go through the last session and create the Snowflake account. That's very important. So before going to start Snowflake sessions, okay, so we are going to talk about SQL. Okay, we are going to talk about SQL. You need to be familiar with SQL concepts. Okay, SQL concepts. So then only can able to understand Snowflake. Okay, as part of today's session, so what is database? What is database? Any idea what is database? What is database?
Collection of data.
Correct. So it is a collection of data. It's a collection of. It's a collection of. It's a collection of data. So what kind of data we are going to store it here? So okay, we are going to store structured, semi-structured, and unstructured data we can store. So mainly we can call it as, it's like a storage location also, okay? So it is a storage location. Then what is warehouse? Data warehouse. What is data warehouse? So here also we are going to store the data. Here also we are going to store the data. We are going to store the data. But the purpose is different. Observe carefully. The purpose is different. So here also we are going to store the data, but the purpose is different. So what is the main difference? Okay, just I'll give you one example here. Okay, I'll give you one example. So you'll go to bank. Okay, you'll go to bank. You want to deposit. Okay, you want to deposit 5K. Okay, so your balance it's already 2K. It is available in now your account. So you are going to deposit means it is going to add 2 plus 5 equal to 7K. It's like immediate reflection. Okay, it's like immediate reflection. It is available. Okay, so this real-time transaction. So this is called real-time transaction or real-time data. Okay, this real-time transactions we are going to store it in our databases. Okay, databases. Then what is the use of warehouse? We are going to store the data, but the purpose is different. Mainly we are going to store it here. It's like historical data and analytical solutions. Okay, so why do we need to store historical data? This is for analytical solutions. Okay, I want to analyze my business. Okay, in which year I got more profit. Okay, in which year it went to loss or something like this. Okay, so that kind of data, it's like large volume of data we are going to store. Large volumes of data we are going to store it in warehouses. Okay, so here you are going to deposit 5K. Now your balance is totally 7K. It's like real-time transaction. Okay, it's like immediate update. Okay, you will get a SMS. You will get an SMS. Hey, your balance is 7K totally. So 5K is updated. Okay, SMS or email. It's like immediate, real time. Now, the same example, you want mini statement, bank mini statement for last 5 years or 10 years. Okay, last 5 years or 10 years data you want to retrieve. So what we are going to do, we are going to online portal. In this online portal, you are going to give the start date first, start date and end date. Okay, start date and end date. So it will take few seconds or few minutes to get it download. Okay, which I have observed from one of the bank. Okay, where I went to online. Okay, so there I can see I have given start date and end date. It took 4 minutes. Okay, 4 minutes to generate the report. So why it is taking this much time? Because all this historical data is going to store it in our warehouses. Okay, our warehouses. So because of that, it is going to take some time to, because of that, it is going to take some time to generate a report. So why do we need to store in warehouses? Okay, so why can't we keep everything in a database? Okay, so here there are some limitations. Okay, there are some limitations. So it may go down. So that is the reason what we will do, even not only banks. Okay, even if you take e-commerce, bank, insurance. So these companies, whatever it is their real-time data, they are going to keep it in databases. Then slowly they are moving into after few days, okay? After few days, it's like 1 month or 2 months or 1 year, they are going to move it into warehouses. From database to warehouse, they are going to ship the data. So if we have a lot of records, then it is very difficult to write a queries. I mean, you can write the queries, but even if you perform select star from table name, so what will happen? Select star from, so employee, where start date and end date, suppose, which you have given. If we have 100 records, it is going to take 0.001 second or something like this. Suppose it contains 20 million records, the response time is very low. The response time is, it is going to take normally 5 seconds or 10 seconds. Okay, something like this. But this is not required. So whatever it is there, I mean, the historical data, we don't use frequently. So that is the reason we are going to store it into data warehouses. Okay. So whatever the data it is available, it's like in real time, which we are going to use it frequently. Those data we are going to keep it in our databases. Okay. So that is the reason the warehouses came into the picture. So here mainly we are going to store it historical data for analytical solutions. So here we are going to store large volume of data. It's like terabytes and petabytes of data we are going to store. Depends on requirement. Okay. What is database here? It is a collection of data. So here also we can store the data. But what is warehouse? Warehouse also we can store the data, but the purpose is different. Database, it's like real-time transactions. It is available. Okay, real-time transactions. But in warehouse, we are going to store historical data for analytical solutions mainly, and future reference also. Okay, we are going to store it in warehouses. Now, database is done. Okay, now we'll talk about SQL. Why SQL came into the picture? Okay, I want to interact my database. Okay, I want to interact my database. Then we need one language. Okay, we need one language. Okay, first of all, we'll try to understand what are the database systems it is available. DBMS. DBMS is nothing but database management systems. Okay, database management systems. What are the database management systems it is available? Okay, first of all, so it is the one of the software application. Software application. Okay, it is one of the software application. So what are the database systems it is available in the market? Okay, there are many. Okay, I'll write few here. Oracle, MySQL, Postgres, MongoDB, Sybase. Okay, there are many. Okay, there are many in the market. There are many in the market, but the purpose is same. Even okay, the vendors is different. If it is Oracle means Oracle company, MySQL Microsoft. Okay, something like this. But what we are doing here also, you can use any database system and we can store the data. Okay, I want to create my employee table. Yes, we can create it in Oracle database or MySQL database or Postgres database. But depends on organizations. Okay, based on cost, which they are going to use it. Okay, okay, they want to prefer. Okay, some clients they are going to prefer Oracle. Some clients they are going to prefer MySQL. Okay, so because of that, there are many databases. How we are using our phones? It's like we do have Nokia, Samsung, iPhone, okay, Redmi, Realme. The same way, what is the purpose of phones? It's like two calls, right? Main purpose is calls and browsing internet. Okay, so all the features it is available in every phone, but it may vary. It may vary, but here also it is like same. So these are the database management systems. It is available in the market. Okay, here we can store the data. Okay, I want to store my data. So how to store my data? So by using SQL. SQL is nothing but structured query language. See, database is different, SQL is different. Okay, many of the students, okay, they are saying, what is SQL? SQL is a database. No, SQL is not a database. SQL is not a database. It's very, very important. Very, very important, this one. Okay, SQL is different and database is different. Okay, these are the database systems. SQL, it's a structured query language. Okay, it's a structured query language. In order to communicate, in order to communicate with any database, we are going to use SQL. Structured query language. In order to communicate with any database, we are going to use SQL. What kind of communication? I'll write here. C, CRUD operations, mainly U and D. C means create. We are going to create the tables. We are going to create the tables and databases, create tables, databases, schemas, okay, etc. Read the data from DB. U, update or manipulations, okay, update the data. D means delete. Every database, if you observe, so these are the actions we are going to perform. So these are the actions we are going to perform. SQL is a structured query language. In order to communicate with any database, we are going to use SQL. So what kind of communication? It's like we are going to perform CRUD operations. CRUD operations. CRUD operations. Okay. So here we do have different types of SQL sub languages it is available. What are those? Okay, what are those? We do have DDL, DML, DQL, DCL, and TCL. Okay, I'll show you the diagram. So this is what we are going to learn in actual classes. Okay, in actual classes. First, what is DDL? Data definition language. So here we do have create, drop, alter, truncate. DML, insert, update, and delete. TCL, commit, save point, rollback. DQL, select. DCL, grant, and revoke. But mainly we are going to work with most of the operations in real time in select only. The 70 to 80%, 70 to 80%, okay, we are going to work with select operations in real time. Okay, so these are the commands. Okay, these are the commands. It is available. Okay, we are going to talk about one by one. Don't worry, but try to understand. Okay, what are the sub languages of SQL? Okay, sub languages. See, SQL, it is very simple. It's like common. It's like a common English language. If you know basic English, okay, if you know basic English, okay, then you can easily learn SQL. You can easily learn, okay. So here, nothing is rocket science. So learn from today, okay, whatever I'm going to teach, okay, that is enough. Just do practice, okay. The practice is very, very important. The practice is very, very important. Now, I'll write few statements here, okay. See, what is my question? First of all, my question is create database with the name as, suppose the name as ViTech. See, what is the question? Create database with name as ViTech. See, the answer is here. See, the question itself, the answer is there. Create database, my database name. That's it. So like this, okay? The question itself, all the answers will be available, but you have to understand the question first, okay? It's very simple. It's very simple. See, create. It is also one of the English word only. So the database, it's a keyword, the database name. Okay, fine. I want to create a schema. Create schema with some name. Okay. How I'm going to create schema. I'll tell you what is schema and all. Schema, some XYZ. Some XYZ. Okay. Or first I'll tell you the definition of schema so that you can able to understand. Just observe carefully. So this is my database. This is my database. This is my database for a bank. Okay. Bank database. So in this bank database, I have some tables. So one table, it's called employee and customers and address, suppose. So EMP table, customers table, and address, okay, or balance or whatever it is, okay. So this is one of the sample table, okay, which I have written here. So it contains rows and columns. What is table? Table is a combination of rows and columns. Let's try to understand why schema came into the picture. I'll tell you. So this is the table. Okay, you can assume. So this is one of the database. In this database contains 3 tables. This database contains 3 tables. Okay. Now you can consider, I want to open, okay, as an user, I want to open an account in HDFC. Suppose you can consider any one of the bank, okay. So I'm going to consider as HDFC. So what I will do, I'll go to online website, and when I'm going to create an account, okay, the customers, I'm one of the customer, my details are going to store it here, okay, one, okay, one, okay, customer is 101 or 102 or whatever it is. So one row it is filled. The bank is okay, HDFC. The bank is HDFC. There is another person. So he want to open an account with the ICICI. ICICI, suppose. So this is the person. So he is also trying to create account, and this person data also it is available in the same table. There is one more person. He is trying to create one account with the access. This person details also it is available here, 103. Now there is another person. My bank name is Santander. It's like a UK bank. This person also want to create account, and this person is number is 104. Okay. See here, what is the problem? See, these are the different vendors. Okay. They are going to, I mean, these customers data, it is available in single table. See, bank is database, but single table, it's available with the different banks data, different banks data. It is not a correct because, so here, there are some security problems will come. So this guy, okay, this person also can access, this person also can access, and this person also can access this table. Okay, they can steal the data or they can modify the data. Okay, so they can do whatever they want. So that is the reason. Okay, later on, so what they have decided. Okay, so why can't we create multiple schemas? Okay, why can't we create multiple schemas? One for HDFC, one for ICICI, but the same tables only. Okay, so one for Axis and one for Santander. One for Santander. So why can't we create? Okay, that is the reason schemas are came into the picture. Okay, suppose. So this is the problem statement here. Okay, this is the problem statement. So all the customers data it is available in, okay, different vendors data it is available in single table itself. They don't want to keep everything in a single table. So they want to separate as a logically. Okay, so schema is nothing but it's a logical representation of, okay, what is schema? I'll write. Schema is nothing but logical representation of database. Logical representation of database. I'll create here. Just observe. I'll take one more here. So after this diagram, then we'll do practically, okay, how to create database and how to create schemas. Now you can assume this is my database. What is my database name? It's a bank. So bank is my database. Okay. Here, first, what they are doing, they are going to segregate into 3 schemas first. 3 or 4, whatever it is. Okay. So this is schema. HDFC, ICICI, or Access. Access. Now, here, inside this, what we are doing? We are going to create separate tables. We are going to create separate tables. The same table name. Okay. We are going to create it. One is EMP. Next one is customer. Next one is address. So here also same table names. So here also same table. So what will happen, okay, if you have multiple customers, if they are trying to create an account, okay, if they are trying to create an account, okay. So we do have one person here. There is another person here, okay. He want to create an account in HDFC, suppose. Then the data is going to store it in HDFC schema with the customer table. So he is from Access or ICICI, okay, Access we can consider. So this guy data is going to store it in to customer table, this customer table, not into this customer table, okay. So this way we are segregating, okay, or separating the tables based on the schema, okay. So these schemas are very, very important, okay. So database contains schemas, schemas contains tables, DST, okay, it's very important. So that is the reason schemas came into the picture. So this way there is no mix of data, okay. So all HDFC related data we are going to store it here. All ICIC related data we are going to store it here. All Access data we are going to store it here. So very important, okay. Now just once again, okay. Schema is a logical representation of database. So logically we are going to represent. Okay, now how to create a schema? Create schema, schema name. Okay, HDFC, my schema. Okay, I want to create 3 schemas. Yes, you can create it. Create schema, ICICI. Yes. I want to create one more schema. Yes, you can create. Okay, let's get started and create one database, one schema, and one table. Okay, for today. So this is the theory. Okay, don't worry about this theory. For today only, okay, for today, I'll give you these class notes in a video description itself. You can copy paste. But in actual classes, we are going to create separate classroom notes. Everything, it is going to get it via email. Okay, automated emails you will get every day so that you can able to copy paste the class notes. That's not a problem. Now, in order to log in, okay, I want to log in into Snowflake. We have a website called app.snowflake.com. Okay, app.snowflake.com. Or what you can do, you can go to your email ID and take that URL and you can log in. So this is my username. Here you can provide your username. Click on this create. Click on this SQL worksheet. Okay, observe here carefully how many databases it is available. So, okay, these are the databases. By default, it came 2 databases. It is available. Now, I want to create one database. Okay. So it is not a case sensitive. Either if you want, you can write it in a capital letters or small letters. That's not a problem. Okay. Create. I want to create database. Database. Create database. My database name is bank. This is my query. Okay. Just observe here. Select this one and click on this run button, or else control enter, or else control plus enter. Select the query, whatever you want to run, then process. And now see database bank successfully created. Okay, I want to know whether it is created or not. There are 2 ways. See here, show. Show is the keyword, show databases. Okay, show databases. Right. Show databases, right? Show databases. See, the bank is created. But here also I want to see just what you can do, just do refresh here. There is a refresh button, just do refresh. See, bank is created. Click on this arrow. So here there are two default schemas it is available, but I want to create my own schemas. I want to create my own schemas. One is HDFC, one is ICICI, one is Access. Okay. How to create? Very simple. Just see here. I want to create schema, right? Create. See the name itself, it is there. Create schema HDFC. Just try to run this. See, it is created. Just click on this one. Again, if you want, you can do refresh. See, HDFC is created. Just do copy paste or 2 times suppose. I want to create one more as Access. See here, I have given in a single, lowercase letters, whether it is going to work or not. Yes, it is going to work. See, now the SQL is not a case sensitive, but the data is case sensitive. Whatever the data it is available in our tables, that is case sensitive. Okay. See here, how simply we have created. Create database and create schema. It's very simple. Now, I want to create a table. Okay, I want to create a table in HDFC. HDFC. See, no objects found. Here also no objects found. Here also no objects found. So what is the first table? I want to create a employee table. Okay. So here it's very, very important. You have to select which database you want to perform. Bank. See, there is one drop down. Click on this drop down. Bank. Click on this HDFC now. Okay, now we are in a HDFC database. Sorry, bank is the database, HDFC schema we are in. Now I want to create one table. Now I want to create one table. So this is my table columns. These are my table columns. Okay, these are my table columns. Just observe here. See, create table. What is the table name? Employee is my table name, or EMP is my table name. Okay, whatever you want, you can keep it. But here, hyphens, it won't support. Underscore, you want to provide. Okay, if you want to write something in SQL, okay, underscores. Okay, so employee is the data, is the table name. Create table, table name. Now, observe here. What are the columns you need to provide? ID, first name, last name, email. Okay, let me write it here. Just open the braces. Okay, just open the brace. See, if you know how to write it for one query, then everything it is same. See, ID. So whether ID, okay, we are going to talk about what are the data types available in next class. Okay, try to understand. So now I'm going to provide ID. It's an integer. So integer means numbers. Next, everything it is a varchar or string. Okay, integer. Give one more enter. Okay, first name. Either you can use varchar. Okay, varchar. The size is the 30. Last name varchar. Okay, let me copy this simply. Okay, so this is size. Column name and data type. Location. Default. So this is how we can create the table. Create table, table name. The column names you need to provide. Next, the data types. Okay. The data types you need to write here. Okay. Now we are in bank.hdfc. So or else what you can do is, there is one more way you can write it here. Okay. Directly create table, the database name. The database name is bank.hdfc. Either you can select from drop down correctly, or else you can write it like this. Okay, you can write it like this. Now let me execute this. Okay, if you want to execute per single query, then you need to select this, then click on this run button. Okay, now see, table employee successfully created. Now I want to see by using query whether it is created successfully or not. DSC or describe. Okay, describe table and table name. Table name. So that you will get to know whether it is created or not, and what are the columns we are using, and what is the data type we are using. ID, number, first name, last name, email, location. Okay, so this is how. Or else what you can do, just do refresh here. See, HDFC table, we do have an employee. Okay, employee is created. So this is the table definition also, it is available. Okay, see here, what is the table definition? How many rows are there? What is the size? Okay, everything it is available here. Now table is created. I want to insert a data. Okay, I want to insert this data. So how to insert this? Okay, how to insert this? Just see now, it's very simple. Insert into table name. What is the table name? Employee. First write all the column names here. See, we do have ID, comma, first name, comma, last name, comma, email, comma, location, comma, department. Okay. Now, what are the values in it to insert? Type values here. See, if you want, you can write it in a single line. You want to write it in multiple lines? Yes, you can write it. Now values. Okay. So this is my first row I want to insert. So if it is ID is integer, okay, no need to keep it in single quotes. So if it is varchar, definitely we need to keep it in single quotes, comma. Just you need to add like this, single quotes, and comma, single quotes, comma, location, okay, these are the values, correct? These are the values we are going to insert. Okay, you want to prepare the query like this. Now let me try to insert this and see. See, it's very simple. Insert into table name, the column names you need to provide here, then values, that's it. Now try to run for one query, we'll see. Okay, one row it is inserted. Okay, I want to see whether the rows are inserted or not. Select star from table name. Very simple. Select star from table name. See, we have one row, it is inserted. Okay. Now I want to insert one more row. Okay, I want to insert one more row. So what you need to do every time you have to prepare a query like this. I'll tell you how to do it bulk insert. Okay. See, I want to insert all these values. Okay. In a single chart. Okay. How we can do? Okay. I'll tell you, but try to understand how insert query is going to work. Okay. Insert into employee. Now, the place of this, just need to write this 3. See again, you have to organize the data. You have to organize the data like this. You have to organize this or arrange. Okay, that's fine. Now you have 1 or 2 rows, then we can do like this. That's not a problem. Now we have inserted 1 more row. I want to validate. In order to validate the values, select star from employee. Okay, fine. So now we have 2. So I have 500 rows or 5,000 rows in my Excel. So how to load this? So do we need to write single query every time? No. So if you want to write like this, it will take 1 day or 2 days, or even for 500 records. Okay. So for that is the reason, so we do have an option. Just do refresh here. Go to this table, employee, click on these 3 dots. See how many rows are there before loading. Just observe here. Select star from employee. Okay, select star from employee. Now load data here. Click on this load data. Click on this browse where the file is located. Okay, where the file is located. Just you need to select this file. In which database and which schema you are using. Okay, bank and HDFC. And which table? Employee table. Correct. Next. So here the file format. What is the file format? It is a JSON or Parquet or XML or CSV. It is a CSV format, comma separated values. Click on this view options. Okay. See here, what is there in first line? It is a header. I want to skip this header. So click on this header, skip first line. Okay, skip first line and click on load data. So here you can see data preview also. Okay, so this is the data preview. Click on this load. See, 100 rows are loaded successfully. Click on done. Now you can see select star from employees. How quickly we have loaded. So that is the beauty of Snowflake. You no need to write. You no need to write manually. Okay, you don't need to write manually the queries handle. So we do have a lot of options. Okay, so even for creation of table, you don't need to write a query also. Okay, I'll tell you later how to do that, but try to practice these queries. See here, now we have loaded the data successfully. Okay, now let's see. Unfortunately, I have dropped my table. Drop table. I'll tell you in a difference. Okay, what is drop and truncate and delete next class. But in this demo, just try to understand. Drop table, table name. Okay, now I have drop my table. If I perform select star from employee, okay, see, object does not exist or not authorized. Okay, unfortunately, I have dropped my table. I have deleted my data and my table also, but I want to recover. So do I need to create a table again and I want to load the data? No. So normally DBMS systems, we need to connect with the DBA, database administrator. So he is going to help us. But here we do have a command called undrop table name. So this is called data recovery. So here you can recover your data. See, earlier we don't have. Now select start from employee. Now we can see. So that is the beauty of Snowflake. See, we can able to see now. Unfortunately, I have dropped my table. If I want to recover my data, yes, we do have an undrop. So this functionality, it is not available in our normal DBMS systems. Okay, so there are many things. There are a lot of things you are going to learn. Anyway, I'm going to provide these classroom notes as well as these SQLs in a video description. Okay, video description. Just you can go through it and practice whatever we have discussed today. It's very, very important. It's very, very important. Just go through once the class video also, just to practice this. Okay, that's very important. So this is about today. So okay, in actual classes you are going to learn more things. Okay, so we do have a lot of options. It's like undrop. Okay, there are many things. It's like time travel is there, zero copy cloning. Okay, so these are the Snowflake features. So everything you are going to learn. So first we are going to concentrate on this SQL roadmap. Okay, first you have to be familiar with SQL. Okay, that is the reason first 5 classes I'm going to take SQL. Then we are going to start with Snowflake. Then we are going to start with Snowflake. Just to go through this. Okay, just to go through this classroom notes once again. Okay, and do practice all the SQLs. That's it for today. Happy learning. We'll see you in a real-time classes. Thank you.